Okay, part 2. Derivatives of exponential logarithmic functions. These are the applications. Right, so we have an online store selling guitar strings. Here is our price-demand equation. Find the rate of change. Right there tells me it's a derivative when demand, x, equals 100. So the first thing we need to do is find the derivative. And this is an exponential with a base other than e. So it's 0.998 raised to the x power, and then the natural log of 0.998. And then we do that when x equals 100. So put 100 in place of x. Type that in the calculator. You will get a negative number. When your natural log value is less than 1, you will get a negative number. You get negative 0.02. And all that tells me is that the price is decreasing. At a rate of 2 cents when the demand is 100. Okay, you're going to try problem number 4. So your problem, you should have got that the price is decreasing at a rate of 18 cents when the demand is 400. 18 cents per blanket when the demand is 400 blankets. Let's look at continuous compound interest. Okay, remember our continuous compound interest formula is A equals PE to the RT. Instantaneous rate of change is the derivative. So the first thing we're going to do is find our AT function with the given information, 10,000, compounded continuously at 4%. So instantaneous is taking the derivative of that. So e to the x is e to the x, but we have to then take the derivative of that exponent, which is 0.04. Simplify this just a little. And then we evaluate that at 2 years. And you get $433.31. So after 2 years, It's growing at a rate of 433.31 per year. Okay, find the instantaneous rate of change and the amount at the time the account has a balance of 20,000. So the first thing you need to do is find time. All right, so we need to do our 20,000. We invested 10, and it's growing at a rate of 4, or compounded continuously at a percentage rate of 4%. So we divide by 10,000. Recall, need to take the natural log of both sides. And then we're going to divide by 0.04. We get 17.329 years. Now we use that in our derivative that we already found. And you get 800. Right, you have match problem number 5 to do. It should just follow right along what we just did. Okay, and then our last example here, using a logarithmic model. So wants us to estimate the number of locations in 2028 and interpret the results, and then estimate the rate of change in the number of locations. So the first thing we need to do is determine the time. If 1980 is times 0, I subtract 1980 from 2028, and it would be 48 years. So we're going to use the original function because that says n of t is the number of locations in year t. And we need to estimate the number of locations. So that's our original function. And we put that in, we get approximately 1,101 or 1,100. If we're going to estimate the rate of change, means we're going to take the derivative of our function. So I'm just going to slide it down just a little bit so that we can take the derivative. Derivative of negative 765 is 0. So the second term there, we have 482 times 1 over t. And 48 years. You get approximately 10. So we have that it would be approximately 1,100 locations growing at a rate of 10 locations per year. You have your last match problem for this section and answer the last of your questions. And this ends part 2.